We are now looking at data distribution and outliers. So if we take a look at the line plot below, line plots are just constructed by having the numbers on the bottom in equally spaced intervals. So this one counts by fives, 20, 25, 30, etc. And an X place on each value. So the first one in the list is 25. So there's an X above the 25. The next one is 30. So there's an X above the 30, and so on. Okay, there are three types of distributions. There are symmetric distributions and skewed distributions, skewed left or skewed right. The data that we are looking at in terms of the salaries is symmetric because it's basically symmetrical on each side. If you were to find the middle of the data, both sides of it would be approximately the same. Skewed right would be if there was only a piece of data or two pieces of data that are further away from all the rest on the right hand side. Skewed left would be the same thing as skewed right, except the few pieces of data that stand out or are different from the rest would be on the left. The next thing I want to take a look at is something called an outlier. An outlier is basically what you think it sounds like. It's something that's outside of the norm of the data. So there's a way to find in whether or not a value is mathematically an outlier, not just looking at it and saying, yeah, it's far away, or no, it's not. So to figure out if something is an outlier, the first thing you have to find is the IQR. Remember to find the IQR. I'll review it again now with a piece of data that we have. You want to look at the data and have them in order from smallest to greatest. Ours are already in order. So the first thing you have to find is the median. So you cross off one from each side until you get to the data value that is in the middle. So in our case, the data value that's in the middle is 40. Then, if you recall, to find the inner quartile range, you have to find the quartile 1, which is the median of the smaller half of data, and quartile 3, which is the median of the upper half of data. So to find the median of each side, remember you're taking the value from the small end and the big end and crossing them out until you find the number that's in the middle. In this case, our number that's in the middle are 35. So we'd have to add them both together and divide by 2. Because the numbers are the same, dividing by 2 would give us 35 once again. So Q1 would be 35. To find Q3, you'd have to do the same thing with the upper half of data. So I'd cross off the 40, the 150, the 45, the 60. But this time the numbers in the middle are 45 and 50. So I would have to find the mean of those two. So I'd have to add 45 plus 50. So I'd get 5, and 5 plus 4 is 9. So I'd get 95. Then I have to divide by 2 because I added two numbers together. So I'd have to take 95 and divide it by 2. 2 goes into 9 4 times. Because 2 times 4 is 8. I subtract and I get 1. I bring down the 5. 2 goes into 15 7 times. Because 2 times 7 is 14. I subtract and I get 1. I have to then add a decimal and a 0 because I'm not done. And then it goes into 10 5 times because 2 times 5 is 10. There's nothing left. So my Q3 would be 47 and a half. To find the difference, we have to then subtract. So I have to add a decimal and a 0 there, and then I can subtract the Q1 from Q3. So 5 minus 0 is 5, 7 minus 5 is 2, and 4 minus 3 is 1. Therefore, our inner quartile range is this value here, which is the 12 and a half. Okay. So once we have our inner quartile range values, you have to take that value and multiply it by 1.5. So if I take 12 and a half and I multiply it by 1.5, I get, so 12.5 times 1.5, right? 5 times 5 is 25, carry the 2, 5 times 2 is 10, plus 2 is 12, 5 times 1 is 5, plus 1 is 6, 0 is my placeholder, and then 1 times 5 is 5, 1 times 2 is 2, and 1 times 1 is 1. Add them together, I get 5. 5 and 2 makes 7, 6 and 2 makes 8, and 1. And I have two numbers behind my decimal, so I move my decimal point in twice, so I have 18 and 75 hundredths. So in order to figure out if a value is an outlier, you have to take the value and determine if it is greater than quartile 3 plus the value you got when you multiplied the IQR times 1.5. So in our case, if we're looking at specifically 150, because that's the only number that really stands out, I would have to take the 47.5 which is the third quartile, and I would have to add the 1.5 times the IQR, which is the 1875 hundredths. If I added 47.5 plus 1875 hundredths, I get 66 and 25 hundredths. So that means anything that's mathematically larger than 66 and 25 hundredths is considered an outlier. Because 60 or 150 is greater than 66 and 25 hundredths, it is most definitely considered an outlier. To find on the smaller end, you'd have to take the value of quartile 1, which is 35, and you'd have to subtract the 18 and 75 hundredths from it. So 35 minus 18 and 75 hundredths is way less than the 25, which is their smallest value, so there is no outliers on the small end.